All right, so we're going to take a look at our second conic section, which is an ellipse. And we'll start out with the definition, and I'll show you a picture of it. So an ellipse, it's a set of or a collection of points in the plane, meaning this is flat. It's not a 3D shape, such that the sum of the distances from two fixed points is always a constant. Okay, so again, an ellipse, it's a collection of points in the plane, the sum of whose distances from two fixed points always comes out constant. So it's kind of similar to a circle. In a circle, we'd say it's a collection of points in the plane, such that all the points are equidistant from a center point. Okay, so a circle is really based off one center point. Well, an ellipse is based off of having 2 points, okay, 2 special points. Okay, so let's take a look at kind of a picture where I can show you the definition. Okay, so here's an ellipse, and the 2 fixed points that I was talking about in that definition are B and C in that picture. Okay? E is a point along the edge of the parabola that I can drag around. Okay? What I'm going to do is I'm going to measure the distance from E to B, and then I'm going to measure the distance from E to C, and then I'm going to add them up. Okay? And right at the top of the screen, it'll do that for me. Okay, so notice as I drag it, the distance from E to B and E to C is changing. But when you add up the distances, it's always 17.3. That's just for this special parabola. It's 17.3. Okay? And there's a little rounding there, but it always adds up to the same thing. Right? Any question on that? And then no matter where you drag it. Add up those two segments, and it always will equal the same number. That's what makes it an ellipse. So sometimes you see, if you study like astronomy, you look at the orbit of a planet, it's elliptical. Some people think it's like circular, the way we go around the planets around the sun. It's not really circular, it's more elliptical. Okay, but that's a use for ellipses, okay, studying orbits. Okay, we won't be looking at that too much. Okay, any question on the definition of an ellipse? Okay, those 2 fixed points that help you to form the ellipse, that you're measuring those distances, those are called the foci. That's the plural of focus. So we don't say focuses, we say foci. Okay, here's a picture. I'm going to go through what all these different things mean. Major axis, minor axis, foci I already talked about a little bit, vertices. Okay, I'm going to define all the words you see in that picture right now. Okay, so let's start with the major axis. Okay, the line that goes right through your foci, it also goes through the vertices. We haven't learned that yet, but you can see it in the picture. The line that goes right through the foci, that's your major axis. Also, another way you can think of the major axis is it goes the long way on the ellipse. So if your ellipse is horizontally, like it is here, the major axis is horizontal. If I took and drew an ellipse like this, now the major axis would be vertical. Okay, so the major axis always goes the long way. The minor axis goes the short way. It's a simple way to think about it. Okay, if you drew a segment from F1 to F2 between the foci and took the midpoint of it, that's the center. So the center is the midpoint of the segment that would join the 2 foci. You could also say that it's the midpoint of the segment that would join the two vertices. Right? It's at the center. Could also say it's where the major and minor axes cross each other. That's the center. So I think the simple way to think of the minor axis is it goes the short way. But if you want a more kind of specific definition, the minor axis goes through the center, and it's perpendicular to the major axis. That's how our book defines it. Okay? Minor axis goes through the center, perpendicular to the major axis. You only have two choices for the direction your major axis is going to go in. It's always going to be horizontal or vertical. Could you have a diagonal ellipse? Absolutely. We won't be studying ellipses that are on a diagonal, though. So I think, in a way, that's what makes ellipses a little bit easier. Parabolas, you had four choices. They could open up, down, left, or right. Ellipses, you have two. They either go horizontal or they go vertical. So you get two options. Okay, and last thing in that picture were the vertices. Okay, so if you draw your ellipse, and then you draw your major axis, where the major axis hits the ellipse, those are your vertices. Okay, so if I scroll up for a second, it's V1 and V2. That's where the major axis hits the ellipse. Where the minor axis hits the ellipse, there's no special name for that. At least not a name that we're going to bother with. Okay, any questions on those terms? Major axis, minor axis, foci, center, vertices.
The line containing the what? The first one.
The first one, the line containing the foci, that's the major axis. Foci. F-O-C-I. It's the plural of focus. Two of them. So some of the terms you see here are the same. Like we had a focus yesterday in a parabola. Today we still have foci, more than one focus. But we didn't have a center yesterday. There's no such thing as a center of a parabola. We didn't have a minor axis. We didn't have a major axis. But we did have a vertex yesterday. Today we have more than one vertex. We have vertices. So it's a little bit of overlap, but not everything.
Is that last word underlined vertices?
Vertices, yeah.
Okay.
Yep, those are your vertices. Okay, any other questions on those terms? So what we'll do, we'll start out with the equation of an ellipse. Just when the vertex is at the center. And then we'll look at what happens when we move the vertex, or I'm sorry, we move it where the center is at the origin. Then we'll see what happens when we move the center off the origin. So the first formulas we look at are kind of the more basic ones, and then we'll look at the general ones after. Okay, so if you want to copy it down, you can, but it is all in your book. It's on page 390. I just copied the whole table from the book. So this is the case where your center is at the origin. Your foci are negative C0, positive C0. Major axis is horizontal. It's the x-axis. And the vertices are negative A0, positive A0. Okay, and here's your equation. X squared over A squared plus Y squared over B squared equals 1. Okay, this is the equation of an ellipse. It always equals 1. It has to. And there's a couple other things that I wrote always have to happen. A always has to be bigger than B. Always. and B has to be greater than 0. So in other words, A and B always have to be positive numbers, never negatives. Okay? A and B are never negative. And a lot of times, we're going to know 2 out of 3 of the letters A, B, and C. Well, this formula right here gives you a relationship between A, B, and C. So if you know A and B, fill them in the formula, you can find C. Now, if you look in the book, it's written a little different than that. What I have here is exactly equivalent to what is in the book. I wrote it like that because when we do something tomorrow, you're going to see a similarity between this and another formula. Okay? All right, so again, if you have your book out, that's going to be helpful. So that way, when we get to all the formulas, if you're just going to make a photocopy of that chart and put it on your cheat sheet, you don't really need to write everything down, and it does take a long time. So. It's on page 390. Okay, this trick the book gives us, I'm not sure that this always works very well, finding the intercepts, the x and y intercept. Well, if you've got an ellipse like this, sure, you've got a couple x-intercepts and a couple y, but what if your ellipse was like this? Now it's never going to cross the x or the y-axis. You're not going to be able to find intercepts. So I'm not so sure that that hint that the book gives is that great. In fact, I probably won't even use that. But it's in the book, so I wanted just to make you aware of it. All right. Now here are the 3 key letters and how you find them. Okay, with a parabola, you just had to find A. Well, with an ellipse, you have to find 3 things, A, B, C. Okay, and on the board, I've quickly summarized how you find them. A is the distance between the center and the vertex. B is the distance between the center and the minor axis, where it hits the ellipse. C is the distance between the center and a focus. Right, so if you just have those 3 things written, you'll know exactly how to find A, B, and C. And in any problem, you never have to find all 3. You only have to find 2, and then use the formula c squared equals a squared minus b squared. Don't mix it up with the Pythagorean theorem. I know it kind of looks like it, but it's not. Okay. Yeah, it's a squared minus b squared. Okay, so again, A is the distance from center to vertex. B is the distance from center to minor axis, where it hits the ellipse. C is the distance from center to a focus. Doesn't matter which focus you pick, center to the one on the left or center to the one on the right, it's right in the middle of the 2. And when we get to H and K is going to be just like it was yesterday. That's the shift, up, down, left, and right. Okay, we're not going to do H and K yet. Okay, so if you need A, B, and C, they're right up here. All right, so let's find the equation here. So our center is 0, 0. Our focus is 3, 0. And our vertex is negative 4, 0. Okay, let's see if we have enough information to find A. Between the center and the vertex, can we find that distance? Sure. The center is at the origin. The vertex is 4 units left. Okay, so what's the distance between the center and the vertex? 4. Okay, B, well, B involves the minor axis. We don't really know anything about B. So let's see if we can find C, the distance between the center and the focus. Okay. How far apart is the center and the focus? 3. One's at the origin, one's 3 units to the right. Now to finish our formula, we really need b, or actually b squared. Yep. So let's find b using the formula. C squared equals a squared minus b squared. Okay, so solve for b, just use your algebra, arithmetic here. 9 minus 16 is how much? Yep, negative 7 equals negative b. Negative on equals a negative on each side. You can cross out the negative. And how would you get b by itself? Square root. Okay, so now we got b. Right, so let's fill in our formula. Okay, so we've got x squared plus y squared. And now we just have to figure out the denominators. Okay, put a squared under x. Okay, a is 4. What's a squared? Okay, b is the square root of 7. So what's b squared? Yeah, we actually had it earlier on. And that's our final answer.
So we just leave it like that?
Yep. You'll never have y or x by itself. Any question on that? Okay, so let's try changing that a little bit. Next time, I'm going to give you an equation, and I'm going to have you tell me some of the information. Okay, so x squared over 25 plus y squared over 9 equals 1. Now, what's going to come in handy here is all of this. The foci are negative C0, positive C0, all that other stuff. So first you've got to figure out A, B, and C. So what's A?
5.
Yep, A is 5. How about B? 3, good. A squared is under, the bigger number is always A squared. Bigger number is always A squared. So if that's A squared, think about the square root. That's how you get 5 and 3. Now to find the foci, we need C. But that's all I can get from the formula. So what do I do to get C? Yep. Equals A squared, yep, minus B squared. So C squared equals 16. So what's C? So C is 4. Now we can write vertices, foci, what else? Center. And let's write which way the major axis goes, if it's horizontal or vertical. Okay, let's start with our vertices. Negative A0, positive A0. All right. Negative 5, 0. Positive 5, 0. Okay, let's go to the foci. Negative C0, positive C0. What are my foci? Yep. 0. Where's the center? 0, 0. We haven't transformed it left, up, down, left, or right yet. So center is 0, 0. Major axis. If you're confused on how you find your major axis, graph your vertices and foci. Are they all on a horizontal line, or are they all on a vertical line? Let's check. Negative 5, 0. That's left 5. 5, 0. That's right 5. Foci. That's 4 left and 4 right. Are those all on a horizontal or a vertical line? They're on a horizontal, so the major axis goes right through all of them.
Because the other way was just very vertical.
Yeah. And a hint, I haven't given you the hint yet, but the way you can tell by an equation whether it's horizontal or vertical, look where the bigger number is. If the bigger number is under x, then the parabola is along the x-axis, the long way. If the bigger number is under y, then the parabola has the long way as y. So wherever the bigger number is, that's the long way of the parabola. Okay? Any question on that? So bigger numbers under x, the long way is going to be x. Bigger number under y, the long way would be y. Okay. Or graph all your points and look at it that way too. Right, so here's another equation of an ellipse. This is on 392. Notice your foci and your vertices, all the x-coordinates are 0. It's the y-coordinates that are changing. You're going down a certain amount and up a certain amount. Vertices down a certain amount, up a certain amount. So if you're going up and down, everything's going to line up vertically now. Vertices, foci, major axis is now vertical. It's the y-axis. Just as before, we can use the formula c squared equals a squared minus b squared. A is always bigger than b, always. And they're both always positive. This formula almost looks the same. Anybody see the difference?
A and B are switched.
Yeah, a and b are switched. Yeah, I just told you before, put the bigger number under y. Now your major axis goes along the y. Put the bigger number under x, the major axis goes along the x. But other than switching a and b, the equation is the same. Still equals 1, still a plus sign, still x squared plus y squared. X will always come first, y will always come second. A and b can switch places. All right, let's try an example. What's different about this equation? We can't discuss it yet. It's not written the way it should be. All equations of ellipses have to equal 1. This equals 9. So what could I do? I got to do it in all 3 spots to change that 9 to a 1. Yep, divide everything by 9. 9, 9, and 9. Okay, 9 divided by 9, that cancels out. So I have x squared. What could you put in the denominator if you wanted to have something there? You could put a 1. 1 squared over 9. And 9 divided by 9, 1. Okay, let's see if we can find A, B, and C. Which one is always bigger, A or B? Okay, so we're going to be looking at the number under y to find a. But remember, the number under y isn't a. It's a squared. So what's a? 3. What's b? It's still 1. It's the square root of 1. And now c? Well, we can find it. C squared equals a squared minus b squared. So c is the square root of 8. We can reduce the square root of 8. We've talked about that before, to 2 square roots of 2. For the purpose of explaining conic sections, I don't think I'm going to do that because I might start to confuse people. But again, remember, square root of 8 can be reduced. Right, so let's write our final answer. So it's x squared plus y squared. Oh, I'm sorry, we already had that part. We need the vertices foci, center, and the major axis. Okay, vertices. 0, negative A, 0, positive A. So what are my vertices? Yep, 0, negative 3, 0, positive 3. Foci, 0, negative C, 0, positive C. So 0, negative square root 8, 0, positive square root 8. Where's my center? 0, 0. We haven't started shifting. Until you see an H and a K in these formulas, there's no shifting yet. All right, so it's 0, 0. Now major axis. Okay, my trick, look where the bigger number is, and that tells you if it goes vertical or horizontal. Okay. Yep, bigger number is under the axis that goes vertical. So this is vertical. Okay, and we're done. Any questions on that one? All right, we'll try one more, and then we got to get into the ones where we have the transformations left, right, up, down. All right. So this time they want the equation. Okay. I think we can get A, the distance between the center and the vertex. Even though they haven't listed the center, 2 reasons. One, our center has been everything for what problem? It's always been what? Yeah, it's always been 0, 0. Even if you didn't know it was 0, 0, I said to you that the center, one way to find it is it's the midpoint between the vertices. So think if you graph those vertices, up 3, down 3. What's right in the middle of those 2 points? Which point? 0, 0. So the center has to be right in between the vertices. 0, 0. So they didn't give us that, but let's write it down. Okay, what's the distance between the center and one of the vertices? How far apart? 3. 3 units apart. B we can't really do much with right now, but C, what's the distance between the center and a focus? 2. Up 2, down 2. The foci are always in between the vertices. The vertices are on the outside, foci are on the inside. And then B. Oh, we need B. Let's find it. So C squared equals A squared minus B squared. Subtract 9. 4 take away 9 gives me negative 5. Negative on the left, negative on the right, that cancels out. And we get B squared. You don't really need B. We need B squared. Okay? But if you wanted B, it's the square root of 5. Okay, and remember what B tells you, bless you. It's the distance from the center to the minor axis. So where B would come in handy, if I was making a sketch. Square root of 5 is about 2.2. So if I'm making a sketch, I went 2.2 to the left and 2.2 to the right. These 4 points give me my ellipse. The 2 vertices. And 2.2 units left, 2.2 units right. My ellipse is going to connect those 4 dots. That's how I would sketch it. So it would be kind of like that. Okay, but now they really want the equation. So all your equations are going to look something like this. You just have to decide what a squared and b squared are and where they go. Major axis, vertical or horizontal? It's vertical. Okay? I could tell that before I even sketched it, just with the points. All right, so let's find a squared. If a is 3, what's a squared? 9. If b is the square root of 5, what's b squared? So where do you want to put the 9? Under the y. Put the bigger number under the y. That'll make that major axis vertical. Put the smaller number under x. Okay, so there's one. They didn't ask us to sketch it, but we sketched it using the 2 vertices and b. B is the distance from center to the minor axis, where it hits the ellipse. So major axis, minor axis. All right, let's look at maybe 1 or 2 where they're shifting. I'm not going to cover this, but a circle, you don't have to write this down. A circle is really a special case of an ellipse. Yep. So a circle is basically an ellipse where it's your major axis and your minor axis. You couldn't tell the difference between it. Right? It's where the 2 numbers in the bottom would be the same. Okay? So if you made, say, x squared over 5 plus y squared over 5, now neither one of them would be bigger. That would become a circle. Okay? So that's all a circle is. It's a special case of an ellipse. So it's where the 2 numbers in the bottom are the same. Okay? I just want you to understand that a circle is a special case of an ellipse. That's it. So if I ask you, like, is a circle a special case of an ellipse, you would say yes. So now we're going to shift it. Okay, this is where the h and the k come in. If you can do everything we did before, then you're going to have no problem with adding in a minus h and minus k. So HK is the center. HK is the center. A, B, and C, all the same. Bless you. A, B, and C, A, B, C, exactly the same. So both of these formulas are on 394. These are the ones, if you're going to put formulas on your cheat sheet, these are the 2 from today that you want to put on. Because these formulas can do everything we did before, and they can handle if you do a shift left, right, up, or down. That's the h and the k. Same rules. A is always bigger than b, and b is always positive. C squared equals a squared minus b squared. Notice the only difference between them is where you put a and b. Put the bigger number under x, make the ellipse horizontal. Put the bigger number under y, make the ellipse vertical.
What page is this on?
394. Okay, so let's try the same thing we did before, except now there's 5 letters you need to find. HK, ABC. We've been doing ABC all along, now we just got to find H and K. Okay, what are H and K again? They're the coordinates of which special point? No, H and K aren't a vertex. They're the center. So an ellipse shifted to have a center of h comma k. HK is the center. Okay, so looking at example 5, the center is 2, -3. Focus is 3, -3. Vertex is 5, -3. What would h be?
2.
Yeah, h is 2. Why? It's the x value of the center. How about k? -3. Okay, that's the new part. That's it. Now we're going to go back to finding a, b, and c, just like we did before. Let's see if we can find a. Center to vertex. Okay, if you're not sure, draw it out. Your center is right 2, down 3. Your vertex is right 5 and down 3. How far apart? 3. The distance between 2 and 5? 2, 3, 4, 5. 3 units. B, we don't know. We'll find B using the formula. C, distance between center and focus. Okay, focus is, I'll do that in a different color. Right 3, down 3. What's the distance between here and there? 1. And now B. How do we get B? Yeah, use the formula. C squared equals a squared minus b squared. So c squared is 1. A squared is 9 minus b squared. Okay, what's 1 minus 9? -8. What can you do with the negative on each side? Cancel it. And b is how much? Square root of 8. That would be helpful if I was going to graph it. I'd go square unit of 8 above the center and below the center. But again, we're not going to graph it. So now we have to decide, is our major axis going through horizontally or vertically? Yeah, it's horizontally. Look at your center, your vertices, and your foci. They form a horizontal line. Okay. So use the top equation. All right, so we have x minus h. And you know what, let's fill it in as we go. What's x minus h? That's 2. Plus y minus k. Be careful there. Yep, it's y plus 3. And now if you want to make your major axis horizontal, do you put the bigger number under x or under y? Put it under x. Okay. So let's see. A squared is 9. B squared is 8. The bigger number this time is 9. Put it under x and you'll go horizontal. Smaller number under y. Yep, that's your equation. Okay. Any questions on that one? Yeah. Yep. So we'll do one more, and then I think we'll stop with that. Any other questions on that one?
Can you go back?
So next one we're going to look at looks a little bit different, but we saw something kind of like it yesterday. We did one in the homework. What do you think I'm going to have to do here? I'm going to have to complete the square, okay? Because this doesn't look like any of the formulas that I've been showing you all along. Notice, though, keep your x's and y's on the same side. We don't put x's and y's on different sides for an ellipse. Okay. What I'd like to do, though, is I kind of want to group the x's together and put the y's together. Okay, so let's do that. Just going to move the 8x over. So we got x's together, we got y's together. What we will do is move the constant to the other side. Okay, when you're going to complete the square for an ellipse, keep your x's and y's on one side, put everything else that's not an x or a y, put it on the other side. Okay. And I want you to kind of look at this as two separate parts. Let's start with the x squared part. Is the coefficient of x squared a 1? No? But what do 4x squared and 8x have in common? A 4. So what I'm going to do is factor it out. That would leave me with x squared minus what? 2x, yeah. Leave a little bit of space here, because you're going to add a number in a second. On the y's, you don't need to do that. It already is a 1, leave it alone. Again, leave a little bit of space after the 4y, because you're going to add another number there as well. Okay, let's start with the first part. What's half of negative 2? 1, yeah. And then square it? 1. What's half of 4? 2, and then square it? 4. So you're completing the square with the x's and then with the y's. Let's see what we really added to both sides. We put a 1 here. We had a 4 on the outside. So what did we really add right here? We added 4. And what did we add right there? 4. So what did we really add on the left? We added 8. So you need to add 8 on the right.
That confused me the way we did that first. Like, I don't understand.
Yeah, we can go through that completing the square. We did that yesterday, but I can show you. All right. So now if you've done it nicely, this should factor two things that are the same. It's going to factor as x minus 1, x minus 1, and so should y. Anybody see what y squared plus 4y plus 4 factors as? Plus 2's, yep. And now we have 4 times x minus 1 squared plus y plus 2 squared equals 4. In my last step, we're just about done. What's it always supposed to equal? It's not supposed to equal 4. Let's divide everything by 4. Those cancel, and there's your final equation. X minus 1 squared plus y plus 2 squared over 4. Now it equals 1. Now you could go through and do that. You could discuss the ellipse. Okay, find the center, find the focus, find the vertex. Okay, so completing the square with an ellipse, it's a little bit more work because you got to do it with the x's separate, and then with the y's. Okay, these are the directions to complete the square. We already went over it yesterday, so you don't need to write that because we already did in the notes yesterday. But if you weren't here, it might be handy to look that up on the video just to see how to complete the square. And don't worry, there won't be too many completing the square ones on the test. Okay, so homework on 397. Okay, it'll be 13 to 17 all. 21, 27, 29, and 39, 41, 45, and 47. 13 to 17, that's a matching. Okay, just like it was last night. So try to use like a process of elimination to try to figure out which ones don't work there. Okay, we'll take a look at that tomorrow.